Hi, I'm Taylor Toby. I'm an OpenSciEd teacher and facilitator, and I'll be walking you through Lesson 2 from the 8.4 unit, Earth and Space. Something I really love about this lesson is it seems very simple and straightforward, but ends with a really rich sense-making discussion in which students are using their observations to make claims. How did we get to this lesson? Students just completed the first lesson of the unit, which is the anchoring phenomenon of Manhattanhenge, and listened to podcasts from around the world. And they figured out that there are these changing patterns in the sky that connect to our daily lives and seem to set the rhythm for life on Earth. And we wonder, are there other patterns that we can notice in the sky? So we decide we want to watch some videos and then develop a model to explain what we think is going on. Looking at this lesson, it is an investigation. It is 1 day long. It's a video analysis. So there isn't much prep work beyond making sure that the links work. It will require devices. It works best if students have access to their own device to analyze the video, but it is possible for you to play the videos for the whole class. Students will watch a total of 3 videos in this lesson and notice that some objects don't move in the night sky while others move in predictable patterns. We end with a sense-making conversation, and students develop an initial model from the perspective of outer space to explain those patterns that they noticed in the video. Students will figure out that Earth's northern axis is pointed at the North Star, which is why it doesn't appear to move in the night sky. The other stars visible at night move in a circle around the North Star, and the sun and the moon both move east to west across the sky. Some key moments in this lesson are part 3. Students will be examining a YouTube video of a computer simulation in which there is a time lapse, so it can cover the span of the whole year, and they can notice objects during the day and at night. During this part, really push students to add details to their observations. Many of my students would be very brief, like, oh, I see the sun move across the sky. And I would need to push them, how is it moving? I would point out that at the horizon, there are these letters, and that can help with direction. Could you draw a picture to show the path that that object is moving, especially in the night sky? It helps when students draw things out if they don't feel like they can describe it in words. As students watch the video, any questions they come up with, you add to the driving question board. In part 4, we have a sense-making conversation where students share out their noticings. We decide what parts we want to put in a model and how they move, and think about what kind of movements are happening to cause what we see in the sky. This will build upon knowledge from 5th grade. So I've run into year to year, depending on the experiences students had at the elementary level. Some will come in having mastered those expectations of what causes day and night, and others have not had any experience at all. So we pause and think about, when would we see the sun? Why would we not see it other times? We have a really quick demo where students stand up and look at a light bulb. We talk about how that is day. The light bulb is representing the sun. The Earth spins around, and so when we are not facing the sun, we say that is nighttime because it is dark. We don't see the light of the sun. Then we can build upon that with other motions that they see, such as the stars in the night sky. We really want to encourage students to use their noticings from that YouTube video to support their conclusions in this model. One of the toughest things is helping them understand, why would the North Star not move? We know that Earth rotates. Why would there be an object that looks stationary? And having them reason through that is really tough at this moment. It really helps to have them get up and physically model rotating around and trying to decide what would be happening to cause one object to appear to be still. Students don't need to figure out that Earth's axis is tilted. We just want them to figure out that Earth's axis at the northern end is pointed at the North Star. Later on in future lessons, we'll realize that the axis is tilted and we'll have evidence to back that up. But at this moment, we don't have evidence to make that claim. This initial model is a really great formative assessment opportunity because students will be drawing and writing, and you get a really clear sense of what they're thinking about Earth's movements from the perspective of outer space at this moment. Where do we go next? We realize that our initial model only explains the patterns we see in a day and night, not over the course of the year. And so we wonder, how can we revise our model to make it better? Here are some tips and tricks for managing the materials with this lesson. With that YouTube video in part 3, it is a very lengthy video. It's over 18 minutes, so definitely chunk it so that way students are assigned parts of the year. And then in that sense-making conversation, they can notice that how the moon and the sun and the North Star and the other stars visible in the night sky move are the same throughout the course of the year. There is the software from Stellarium that you can use directly in place of the video. There are reference materials for you to access how to do that. But the YouTube video is very easy to share and more than sufficient for students to notice everything they need to. Word wall management. We don't earn any words in this lesson, but due to students' differences in background knowledge coming into this unit, you may encounter words like rotate or revolve. And during this conversation at the end of lesson 2, it's a really good time to make sure that everyone is on the same page with what these words mean and what kind of motions go with them before moving on. Poster management. You will be referencing the patterns in the sky poster you created in lesson 1 during your conversations. And then in lesson 2, you will be creating a poster for those model components that students think they should include in their initial model and descriptions of how they appear to move in the sky. You'll want to save that. Students will be using it in their initial model as well. We'll be building upon that in future lessons, so keep that handy. Thank you so much for joining me to hear about lesson 2. To summarize, students will be watching a series of videos, and we want them to figure out that the North Star does not move because Earth's axis is pointed at it. Reminders, they don't need to include that Earth's axis is tilted at an angle. We'll get to that later. And that Earth's rotation is what's causing the sun and the moon to move east to west across the sky and to cause those other stars visible in the night sky to move in a circular path around the North Star. Thank you again, and I will see you in lesson 3.